Once upon a time, there were two brothers, integral root tan x dx and integral root cot x dx. Their name was I and J. So now, in this video, we are going to solve these two integrals. Now, for solving these two integrals, it's basically easier like if we try to integrate their sum and their difference. It will be easier to integrate these two things, and later on after we solve for m and n, then we can find I by doing m plus n by 2 and j by m minus n by 2. So this is the technique that we will use. Now let's begin. Let's integrate the I plus j. So m is integral of root tan x plus root cot x dx. Now to integrate this, first of all we'll use their formula. This is root sin x by root cos x, and this is root cos x by root sin x. Yeah, root sin x by root cos x plus root cos x by root sin x dx. Now after this, take the LCM. That gives us sin x plus cos x by root under, this is sin x cos x. Now in this scenario, what we can do is, if we make a substitution du such that it gives sin x plus cos x dx, in that case our u will be expressed, our u can be expressed in terms of these expressions. Let's see how can we express our u in terms of these. So our u is basically, if we just integrate this, we will have minus cos x plus sin x. Yeah, now our u square will be cos square x plus sin square x minus 2 sin x cos x. Yeah, so that's 1 minus 2 sin x cos x. So now I think you have seen how can we express our u in terms of these expressions. So now our 2 sin x cos x will just be 1 minus u square. Yeah, and then our sin x cos x will be 1 minus u square by 2. So in this way, this helps us a lot now, because now it will be simplified a lot. Now this will just be du by root under 1 minus u square by 2. Now root 2 can be taken out. Now this is just integral of sine inverse u. Yeah, plus c, and u is sin x minus cos x. Yeah, so you see, this was really simple integral, plus c. Now we solve this. Now let's solve the other part. The other part is over here, I minus j. This one is also similar, this is not different, so you can try on your own as well. Yeah. Root sin x by root cos x minus root cos x by root sin x and then dx. Now this is equals to sin x minus cos x dx by, this is root under sin x cos x. Yeah. Now again this is similar. What you can try to do is, you can try to find a u such that du is sin x minus cos x dx. Now for that, a u should be minus cos x minus sin x. Yeah. So now if you have to express in terms of this, you can square. U square equals to, this will be 1 plus 2 sin x cos x. Yeah. And now sin x cos x will be u square minus 1 by 2. That's simple. And then what will we get? We will get, this is du by root under u square minus 1 by 2. Now root 2 can be taken outside. Yeah, and then du by root under u square minus 1. Now in this, you should know that if we have dx by, let me also show you how does this work. This integral x square minus 1 dx, this is actually equals to cos h inverse x. Let me show you how with a different color. So basically, if you let x as cos as theta, our dx will be sin as theta d theta. Yeah, okay, so I have written 2 dx over here. So then our dx is sin as theta d theta, and over there also it will be sin as cos as square theta minus 1, and that is again sin as theta. So sin as theta by sin as theta d theta, and now this cancels out. What remains is theta plus c, and what is theta? Theta is cos h inverse x. So this is how it's derived. Yeah. Okay, now this is root 2 times cos h inverse u plus c. Now our u is root 2 times cos h inverse, what is our u? U is, what's the u? Minus cos x minus sin x, minus cos x minus sin x plus c. Now the minus can be taken out, but let me show you how. First. Okay, so let's say we have cos h inverse minus x. Yeah. Now the logarithmic expansion for cos h inverse x is ln of x plus root x square minus 1. Actually it's plus minus, but let us just write plus, because to be sure that the value is positive, let us just write plus. Now this can be written as ln of minus x plus root under x square minus 1 plus c. Now since we cannot be sure if this is positive or not, but ln needs it to be positive, so what we can do is we can just take minus sign and then reciprocal it. Yeah. And now we can multiply by minus x minus root x square minus 1 by minus x minus root x square minus 1 plus c. Yeah. Now after this we will have minus ln of, this gives us minus x minus root x square minus 1 by, this is what it is, a plus b a minus b. This is x square, yeah, a plus b minus b, a square minus b square, a square minus x square minus 1 plus c. Now this is minus ln of minus x minus root x square minus 1, and this is just 1 plus c. Now since this is modulus, we can change both of these signs into positive sign. Yeah, so minus ln of x plus root x square minus 1. Now in this case, since both of these are positive values, so it's sure that there's a positive value inside. So this is just cos x. So sorry, cos inverse x minus cos inverse x plus c. Okay, plus c. So I just showed that cos inverse minus x is minus cos h inverse x plus c. That's why what we can do is root 2 and then minus cos h inverse sin x minus 1 minus 1, sorry, let me write it again. So this is minus root 2 cos h inverse sin x plus cos x plus c. So this is our second integral. This is our j, yeah, and our I is, this is our j and our I is over here. Okay, so let me write both of them now. Our I was what was it, root 2 times sin inverse sin x plus cos x, sorry, sin x minus cos x plus c. Yeah, let's just check. Yeah, and our j is minus root 2 times cos h inverse sin x plus cos x plus c. Yeah, now we can find sorry, these are not I and j, these are m and n. So this is actually n and this is m, this is n. Now our I, the root 10x is just the sum of these two. So root 2 sin inverse sin x minus cos x minus root 2 cos h inverse sin x plus cos x by 2, and j is root 2 sin inverse sin x minus cos x, and then plus root 2 cos h inverse sin x plus cos x by 2. So these are the answers for these integrals. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.